Welcome back to Silent Science World, the place where quiet minds come to rest beneath the stars. Tonight we are drifting toward one of the oldest riddles our species has ever looked up and wondered about. Comets are not simply glimmers passing through the dark. They are frozen fragments left over from the very first moments of our solar system, older than any ocean, older than any mountain, older than the ground beneath your bed right now. Long before our planet had rivers or rain, these icy wanderers were already taking shape in the freezing emptiness that surrounded our young sun. For nearly all of their existence, they stay hidden, drifting far past the orbits of the planets, in a region where sunlight is little more than a rumor and where time seems to lose all meaning. But every so often, something shifts. A tug of gravity nudges their path inward. The distant sun begins to reach them with real warmth, and the ice that has slept for eons starts turning into vapor. A quiet, dark little world suddenly begins to glow. To the earliest people who watched the sky without any understanding of orbits or physics, a sight like this could feel like an omen, a message sent down from somewhere unknowable. But to us, with all we have learned, a comet carries a different kind of message. It is a courier from the childhood of our solar system, and it may hold pieces of the puzzle that explain how our own world came to exist at all. If tonight's journey brings you a little peace, feel free to leave a like or a quiet word below before you drift off. It helps this small corner of the internet find its way to other sleepy minds. But there is no need to think about that now. For the next while, all you have to do is let your body sink a little deeper into the mattress. Let your shoulders loosen. Let your breathing slow down, one soft breath at a time, as we travel together through the cold, silent reaches of space. Let's begin. Comets are ancient leftovers from the earliest days of the solar system, long before Earth had oceans, mountains, or even a moon circling it. Countless grains of dust and specks of ice were spinning in a slow cosmic dance around our newborn star. Most of that raw material eventually clumped together to form the planets we know today, but not all of it. Some of it was pushed out to the frozen edges of the system, far from the gathering worlds, and left to drift. Those leftover pieces became comets. They are more than simple chunks of frozen rock. Think of them as tiny time capsules, sealed shut for billions of years. Inside each one are ices, minerals, and carbon-rich compounds that have barely changed since the solar system's earliest hours. When researchers study a comet up close, they are not just examining a lonely object tumbling through space. They are reading a message written in the raw ingredients of creation itself. A comet might look small and unremarkable from our vantage point on Earth, yet it carries memories older than every living thing that has ever crawled, swum, or flown across our planet. A comet can grow a glowing head far larger than the biggest planet in our solar system. The solid center of a comet, its nucleus, might only stretch a few miles across, small enough to fit inside a modest city. But once it drifts close enough to the sun, everything about it begins to transform. Heat coaxes frozen gases loose from the surface, and as those gases escape, they drag fine dust particles along with them out into the surrounding vacuum. Around that tiny core, an enormous hazy cloud begins to form. Astronomers call this cloud the coma, and it can swell to a truly staggering size. In some cases, this glowing envelope grows wider than the largest planet in our solar system, meaning a frozen body no bigger than a town can, for a brief while, wear an atmosphere vaster than a gas giant. The scale of it feels almost impossible to picture. A dark, ancient lump of ice, smaller than a city, can bloom into a glowing presence that fills an enormous stretch of space, only to fade back into a quiet, invisible traveler once it moves away from the sun's warmth again. The tails that trail from comets can stretch across millions of miles. It's tempting to imagine a comet's tail dragging behind it the way smoke trails behind a moving train. But the truth is far stranger. A comet's tail is shaped not by its motion but by sunlight and the endless stream of particles flowing outward from the sun, known as the solar wind. As a comet drifts inward, material pours off its surface and spreads out into a shape that can dwarf entire planets. Some of these tails are so immense that our own world could fit inside their length many times over, and yet the material itself is astonishingly thin, more like a faint veil of mist than any kind of solid trail. From far away, it glows with breathtaking beauty. Up close, it would feel like almost nothing at all, a near emptiness lit only by scattered light. That contradiction is part of what makes comets so mesmerizing. They can paint grand, radiant streaks across the sky, while being made of little more than scattered particles thinner than any cloud that has ever drifted over our heads. Every comet's tail points away from the sun, no matter which direction the comet itself happens to be traveling. It feels natural to assume that a tail should trail behind the object's motion, but comets follow a stranger rule entirely. Their tails are steered by the sun's radiation and its outward wind of particles, not by the comet's own path through space. As a comet loops around the sun and starts heading back toward the outer darkness, its tail can actually point ahead of it, reaching forward into the direction it is about to travel. The comet moves one way, while its glowing tail reaches another. This small, strange detail reveals something we cannot otherwise see. Space is not simply empty and still. It is filled with pressure from light, invisible magnetic fields, and constant streams of particles pouring outward from our star. A comet makes these hidden forces visible, much like a weather vane turning quietly in a wind we cannot feel ourselves. Some comets may carry the building blocks linked to the chemistry of life. On the surface, comets seem frozen, dark, and utterly lifeless, and yet their chemistry can be remarkably rich. Instruments aboard spacecraft and telescopes have detected carbon-based molecules inside comet material, some of them related to the chemical processes used by living cells here on Earth. This does not mean comets are alive, or that they contain life in any form. It means they carry some of the raw ingredients that life, once it exists, knows how to use. In the earliest days of the solar system, collisions and impacts were far more frequent than they are now. Comets and other icy bodies may have delivered water, carbon compounds, and other volatile materials to the young, forming worlds around our sun. Earth was not born complete and finished. It was shaped gradually, through bombardment, heat, the slow filling of oceans, and countless chemical reactions. Comets may have played a quiet part in that long story, carrying fragile molecular seeds inward from the frozen outskirts of the solar system toward the warmer region where our planet was still taking form. One particularly famous comet has returned to our skies again and again across thousands of years of recorded history. Long before anyone understood orbits, gravity, or the true physical nature of comets, generations of people watched this same visitor cross their skies. Ancient records from several different cultures describe bright comet sightings that line up with its predictable return. To those early observers, it was never seen as a predictable traveler on a fixed schedule. It was a sudden blazing sign appearing in the heavens without warning or explanation. It was only much later that astronomers realized many of these historical sightings, recorded centuries apart, actually described the very same object making its way back again and again. That single discovery changed how humanity understood comets altogether, transforming them from mysterious omens into worlds following predictable paths through space. What makes this story so remarkable is its human continuity. People separated by empires, by languages, and by thousands of years all looked up and saw the very same icy traveler pass overhead. It has swept above farmers, rulers, monks, scientists, and modern cities alike, quietly linking generation after generation through one visitor that keeps coming back from the darkness beyond our world. In the mid-1990s, a comet broke apart and collided with the largest planet in our solar system, leaving scars as wide as entire worlds. Astronomers watched in real time as the broken fragments struck one after another, and dark marks bloomed across the giant planet's swirling cloud tops. Some of those impact scars were comparable in size to Earth itself. The event proved, in front of watching telescopes, that our solar system is still active, and at times, still capable of real violence. The giant planet's immense gravity had pulled the fragile comet apart long before it ever reached the atmosphere, breaking it into a chain of separate fragments. When those pieces finally struck, they released staggering amounts of energy into the clouds below. For countless observers, it became the first modern, unforgettable reminder that cosmic collisions are not confined to ancient history. They can happen while our own telescopes are pointed directly at the sky, watching it unfold. Most comets spend the overwhelming majority of their existence frozen and hidden in deep darkness. The spectacular, glowing chapter of a comet's life is usually brief. For most of its long existence, it drifts far from the sun, cold, dim, and almost completely invisible. Out there, its ices remain locked solid, and the comet shows no tail, no glowing halo, nothing but a silent shape moving slowly along its ancient path, sometimes for centuries, sometimes for many thousands of years. Then, a small shift in its orbit can bring it inward once more. Sunlight returns, frozen gases begin to stir and awaken, and the hidden body transforms into a brilliant, luminous visitor. This rhythm gives comets an almost dreamlike quality, as though they were sleepers themselves, spending long ages resting in silence, preserving ancient material in the cold, before one close approach to the sun briefly turns them into a wonder visible across the entire night sky. Beneath its shining halo, a comet's core can be darker than a lump of coal. The glowing beauty we admire from a distance can be deeply misleading. Beneath the bright coma, the nucleus itself is often extremely dark, its surface coated in dust and organic-rich material that reflects only a tiny fraction of the sunlight striking it. In close-up photographs taken by spacecraft, comet nuclei can look rugged, blackened, and surprisingly rough, marked with cliffs, pits, and shadowed plains. Nearly all of the brilliance we see from Earth comes from the gas and dust surrounding the nucleus, not from the surface of the body itself. This creates a fascinating contradiction. One of the most luminous objects in our night sky may actually have a heart that is almost entirely black, like a lantern glowing softly around a lump of charcoal. The light we see is temporary, created by the warmth of the sun, while the ancient, dark relic underneath remains hidden inside its own glow. Far beyond the orbit of the outermost planet, and stretching even further beyond the region we typically call our solar system, astronomers believe there exists an enormous, distant reservoir of icy bodies. This far-off shell has never been directly observed as a whole, but the orbits of comets that take extraordinarily long to circle the sun point strongly toward its existence. A passing star, a gentle gravitational tide from our galaxy, or some other disturbance can nudge one of these frozen bodies inward, sending it falling toward the sun from a distance almost too vast to picture. These particular comets can arrive from seemingly any direction, as though dropped in from the outer darkness itself. Their long, strange journeys remind us that our solar system stretches far beyond what the planets alone would suggest, with a distant, silent frontier full of frozen, sleeping worlds we may never fully map. Comets are sometimes nicknamed dirty snowballs, but that description barely scratches the surface. The phrase makes them sound almost simple, as if a comet were nothing more than a lump of ice mixed with a bit of dirt. The truth is far stranger and far more interesting. A comet is a layered archive built from frozen gases, rocky grains, carbon-rich material, minerals, and ancient chemistry, all preserved together in extreme cold. Some sections may be fragile and powdery. Others may be tougher, crusted over, or fractured from repeated passes near the sun. And the ice inside is not simply ordinary frozen water. It can include frozen carbon dioxide, carbon monoxide, methane, and a whole range of other frozen substances that behave in very different ways once exposed to sunlight and the vacuum of space. So that old playful nickname captures only a small corner of the real story. These are not messy snowballs drifting aimlessly through emptiness. They are complicated little worlds, built from the raw ingredients that eventually form planets, then locked away in darkness until warmth finally reveals their hidden nature. An icy nucleus can be no larger than a small town, and yet it is capable of producing a truly grand display. The solid core of a comet may measure only a handful of miles across, roughly comparable to a modest town or a district within a city. Yet that compact body can hold enough volatile material to create an enormous glowing cloud and sweeping tails once it is warmed by the sun. If you could somehow stand upon its surface, the landscape might resemble a frozen wasteland of pits, ridges, dust, and long shadows. There would be no wide, familiar horizon like the one a planet offers, only a small, curving world falling away quickly beneath your feet. Its modest size also means extraordinarily weak gravity, so loose material can drift off with surprising ease. A small nucleus becomes magnificent not because of its size, but because it needs only 3 simple ingredients to put on its show: sunlight, ice, and time. Sunlight has the power to turn a comet's frozen ice directly into gas. Here on Earth, ice typically melts into liquid water before it eventually evaporates. But in the near vacuum surrounding a comet, that process can skip the liquid stage almost entirely. As sunlight gradually warms exposed ice, molecules break free and escape directly into the surrounding vacuum of space. This process is known as sublimation, and it is one of the central reasons comets seem to come alive as they approach the sun. Frozen carbon dioxide and carbon monoxide can begin escaping at far colder temperatures than ordinary water ice, meaning a comet's activity can start while it is still remarkably far from the sun's warmth. As gas rushes outward from the surface, it carries tiny grains of dust along with it, transforming a dark, hidden nucleus into a visible, glowing object. It is genuinely beautiful physics in motion. A touch of warmth reaches ancient ice, and a body that has slept for ages begins releasing its long-stored breath out into the open dark. A comet's glowing coma forms as trapped gases finally burst free into space. The bright haze surrounding a comet begins close to the surface, where warming ice releases gases that have remained sealed away for immense stretches of time. As those gases escape, they spread outward in every direction at once, since there is almost no surrounding air pressure to hold them back. Fine dust is carried along with them, and sunlight catches this expanding cloud, giving the comet its familiar soft glowing appearance through a telescope. The coma is not some solid fixed shell. It behaves more like a temporary atmosphere, constantly refreshed by new escaping material and constantly being lost back out into space. Its shape can shift as different regions of the nucleus warm up, crack open, or rotate into direct sunlight. What we are really watching is not a still, unchanging halo, but a living, ongoing process. The comet is quietly shedding itself, moment by moment, as ancient stores of gas stream endlessly away into the surrounding dark. Dust tails curve gently because sunlight steadily pushes their fine grains behind the comet's path. A dust tail forms from tiny solid particles released from the comet's surface. Once free of the nucleus, those grains no longer follow its exact path. Sunlight itself carries a small amount of momentum, and that faint pressure gradually pushes on the drifting dust as it moves through space. Larger grains respond slowly to this pressure, while smaller ones are swept farther and faster, creating a broad, gently curved tail that can resemble a soft brushstroke painted across the night sky. That elegant curve reveals both the comet's own motion and the steady outward pressure of sunlight working on it. It isn't random decoration scattered across the heavens. It is physics quietly drawn on a truly cosmic scale, with every individual grain tracing its own unique path, shaped by gravity, sunlight, and the exact speed at which it first escaped the nucleus. Together, all of those tiny paths combine to create one of the most graceful structures found anywhere in astronomy. A second kind of tail can glow with a distinct bluish light as the solar wind sweeps charged gas away from the nucleus. Some of the gases escaping a comet become electrically charged once sunlight strips away their electrons. Once charged, these particles respond strongly to the solar wind, the constant stream of particles flowing outward from our star, and this interaction creates a narrow ion tail that often appears bluish in photographs. Unlike the broader dust tail, this ion tail tends to point almost directly away from the sun, closely tracing the exact direction of the solar wind. Its glow comes from molecules and ions interacting with both sunlight and space particles, particularly carbon monoxide ions found in many comets. What makes this second tail so fascinating is that it behaves like a visible instrument, silently measuring forces we could never otherwise see. It turns an ordinary comet into a natural detector of the sun's activity, translating invisible solar behavior into a glowing streak we can observe from millions of miles away. Some comets display two separate tails, each pointing in a slightly different direction. A particularly bright comet can appear to unfurl more than one glowing banner across the sky at once. One tail is typically made of dust, pushed outward by sunlight, and spread into a soft, curving fan shape. The other tail is made of charged gas, swept more directly outward by the solar wind into a straighter line. Because dust and charged particles respond to entirely different forces, these two tails can separate and stretch along noticeably different paths through the sky. This gives certain comets a striking, almost double appearance, as though two different stories were being told side by side. One tale speaks of solid grains shed from the comet's surface. The other speaks of charged particles caught within the sun's invisible outward stream. Seeing both together is a quiet reminder that a comet is never simply glowing on its own. It is actively interacting with the entire surrounding space environment around it. On rare occasions, a comet becomes bright enough to spot without any telescope at all. Most comets remain faint, distant objects, known only to observers equipped with proper instruments. But every so often, one brightens enough for ordinary eyes to notice. This can happen when a comet passes unusually close to the Sun, close to Earth, or releases a larger amount of gas and dust than usual. In these moments, it may appear as a soft, glowing patch in the sky, occasionally trailing a faint tail behind it. For people who rarely think to look upward, a sight like this can feel genuinely startling. It is not a planet, not a star, and not a passing cloud. It is a moving visitor from the coldest, most distant reaches of our solar system, briefly bright enough to enter human awareness without the need for any machinery at all. These rare naked eye appearances matter because they briefly bring the depths of space into plain sight, turning an ordinary night into a shared moment for anyone who happens to glance upward. Every so often, a comet becomes so bright and so extended that it stops being merely a target for astronomers and becomes part of ordinary daily life. People begin noticing it after sunset or just before dawn. It gets mentioned in conversation. Photographers chase it across the horizon. Children ask what that strange glow drifting overhead could possibly be. These especially memorable visitors are sometimes called great comets, not because of their sheer size, but because of the lasting impression they leave behind. Their brightness depends on a combination of factors, including distance, the amount of dust they produce, their geometry relative to the Sun and Earth, and how effectively their tails catch and scatter sunlight from our particular point of view. Some become genuinely unforgettable, hanging quietly in the twilight with a visible plume that shifts subtly from one night to the next. They remind us that the sky above us is not fixed scenery. It can suddenly reveal motion, depth, and a sense of history that feels almost personal. To ancient observers, the sudden arrival of a comet could feel deeply unsettling. Before the rise of modern astronomy, everything else in the sky seemed orderly and predictable. The stars held their positions. The moon moved through its familiar phases. The planets wandered along known, repeating patterns. Then, without any warning at all, a strange blurred light might appear, slowly grow a tail, and begin moving against the otherwise familiar backdrop of the constellations. Many cultures across history connected sights like this to the fate of kings, the outcome of wars, coming disasters, or great turning points in their societies. This was never simple foolishness. It was a very human attempt to find meaning inside an unpredictable sky. Comets looked unlike anything else people already understood, and their timing so often felt impossible to ignore. Over time, patient and careful observation gradually transformed that early fear into genuine knowledge. And yet those older reactions still tell us something important about ourselves. Comets have always carried real emotional power. Long before they were understood as icy wandering bodies, they served as reminders that the heavens could still surprise us. Centuries of careful skywatching in ancient China produced some of the most valuable comet records in human history. Court astronomers treated every unusual change in the heavens as a matter of genuine importance, carefully noting the date, position, brightness, shape, and movement of anything unfamiliar with remarkable discipline and consistency. These historical records often describe comets as broom stars, inspired by their long, sweeping tails. For modern scientists, these ancient notes are far more than simple cultural history. They can help identify earlier appearances of well-known comets and help reconstruct exactly how their orbits have changed and evolved over enormous spans of time. A single note, carefully written by a court astronomer many centuries ago, can still matter to astronomy today. There is something wonderful in that quiet continuity. A careful observer standing beneath an ancient sky could never have known anything about spacecraft, spectroscopy, or orbital simulations. And yet their patient, careful notes became part of a scientific chain reaching all the way into our present moment. For a very long stretch of history, comets seemed like one-time intruders into an otherwise orderly sky. They would appear, brighten, gradually fade, and vanish back into mystery. The great turning point came when astronomers began comparing historical records of past appearances and realized that some of these sightings might actually describe the very same object, returning again and again along a long looping path around the sun. This discovery reshaped the way people understood the entire sky, transforming a once frightening apparition into a predictable, returning traveler. The idea itself was bold, precisely because the comet in question would vanish for an entire human lifetime before finally returning. And yet the prediction held true. When it eventually did come back, it proved that mathematics alone could reach far into the darkness ahead and accurately describe the path of a body that no living observer had ever personally watched complete a full journey. Comets also played a critical role in testing one of the most important ideas in the history of physics, the law of gravity. Comets mattered deeply to the rise of modern science precisely because they never moved in neat, simple circles. Instead, they followed long, stretched, sweeping paths that carried them far from the sun, before pulling them back again at tremendous speed. It was understood that the same gravitational force pulling an ordinary object toward the ground could also guide moons, planets, and comets alike across the vastness of space. Their motion offered a genuinely severe test of this idea. If gravity truly reached across all of space, then a comet's curving path should be fully explainable, using the very same principles that governed the orderly motion of the planets. This realization amounted to a breathtaking unification of ideas. The heavens were no longer treated as some separate realm operating under entirely different rules. A comet sweeping silently across the sky became living evidence that nature relies on one single, consistent set of laws. From the surface of our own planet all the way out to the farthest edges of the solar system. Its curving path helped reveal a universe held together by an invisible, constant attraction stretching between every object within it. One especially bold prediction claimed that a particular comet would return long after its original observer had passed away. Making such a claim required far more than simple cleverness. It demanded genuine confidence in historical records, careful mathematics, and the deeply held belief that a comet no longer visible could still be quietly following a hidden, predictable orbit through the darkness. By studying earlier historical appearances, it became clear that sightings recorded across very different centuries shared remarkably similar paths. Rather than describing many separate comets, they seemed to describe one single body, returning again and again on a long, looping journey. The prediction stated it would return only after its original observer was gone. That kind of claim carried real weight because nobody could simply step outside on a clear night and check whether it was true. The answer belonged entirely to the future. When the comet eventually did return exactly as predicted, it became one of astronomy's great triumphs, proving that careful human reasoning could outlive the person who first proposed it, reaching forward through time to greet a returning icy traveler on its next arrival. That same famous comet last swept through our skies decades ago. That particular return wasn't the most spectacular one for casual observers, since the viewing geometry from Earth wasn't especially favorable at the time. Even so, it became a genuine landmark moment for space exploration. For the very first time, spacecraft from several different nations were sent out to study the comet up close. The images they captured revealed a dark, irregular nucleus quite different from the shining object many people had long imagined. Jets of material burst from active regions across its surface, spraying gas and dust out into space as the comet swept nearer to the sun. That visit connected ancient skywatching directly with modern engineering. A body first recorded by people thousands of years earlier was finally photographed up close by machines built here on Earth. Its next return will belong to an entirely different generation, giving this particular comet a rare and deeply human emotional rhythm. It isn't just a distant object drifting through space. It is something closer to an appointment stretched across separate lifetimes. Few comet stories carry as much strange poetry as the tale of a well-known writer whose life became strangely bound to one famous comet's visits. Born shortly after its appearance in the early 19th century, he openly expected he would leave this world alongside it when it eventually returned. Remarkably, he passed away just as that same comet was once again sweeping past Earth. The timing wasn't mystical in any scientific sense, but as a purely human story, it remains genuinely unforgettable. A writer known for his wit and his deep sense of cosmic irony found his life quietly bracketed by the very same celestial visitor. It's a gentle reminder that comets are never only astronomical objects. They quietly weave themselves into culture, memory, literature, and deeply personal meaning. Their long cycles make individual human lives feel remarkably brief, and yet they also give us a way to measure time against something genuinely vast. One particular comet from the late 1990s remained visible for an unusually long stretch of time. While many bright comets flash through our skies and vanish quickly, This one was different. For month after month, it stayed visible to the naked eye, becoming one of the most widely observed comets of modern times. Part of its lasting impact came from that unusual persistence. People could return to watch it night after night, not as a brief, fleeting surprise, but as an ongoing presence quietly hanging in the sky. It possessed an unusually large and active nucleus, producing a tremendous quantity of dust and gas that helped it remain bright across many weeks. For countless observers, it became a shared memory of simply stepping outside and looking up. Long before glowing screens filled every pocket, millions of people did exactly that, and saw a genuine comet with their own eyes. That single object turned astronomy into something public, patient, and truly unforgettable. Another remarkable comet became one of the brightest ever captured on camera during the mid-2000s. This particular visitor put on a dazzling display, especially for observers positioned in the southern hemisphere. Its tail spread outward into a broad, fan-like shape, marked by delicate bands that looked almost too structured and precise to be entirely natural. Photographs captured it glowing brilliantly after sunset, and for a short while it was even visible in broad daylight under the right conditions. Its beauty came from sunlight scattering off drifting dust, arranged by the combined effects of motion, radiation pressure, and viewing angle. What made this comet so memorable wasn't only its brightness, but its elegance. Its tail seemed to open like a vast celestial fan stretched above the horizon. Comets like this remain rare because so many separate conditions must align perfectly at once. When they finally do, the result is a powerful reminder that our solar system can still produce spectacles grand enough to stop people in their tracks. Yet another comet gave modern stargazers a rare naked-eye display during an unusually quiet year for the entire world. It was first detected by a space telescope designed to survey infrared light, and it soon became an unexpected gift for people back on Earth. It rose before dawn at first, then became easier to spot after sunset as the days went on. Under sufficiently dark skies, observers could spot its bright head and graceful tail without any telescope at all. Cameras revealed even finer structure, including a separate ion tail glowing faintly beside the broader dust tail. Part of its charm came from how accessible it was. You didn't need to be an expert to find it. You only needed a clear horizon and a genuine reason to look up. For many people during that particular year, it became a shared moment of quiet wonder, proof that the sky above could still surprise all of us, even during difficult times. Before its dramatic collision with a giant planet in the mid-1990s, one comet broke apart under the pull of overwhelming gravity. Before impact, the planet's immense gravitational field had already done something dramatic, pulling the comet apart into a long chain of separate fragments, stretching and tearing the body until it resembled a string of pieces traveling along the very same doomed path. Images captured before the eventual collision showed a broken chain rather than a single solid object, often compared to pearls strung along an invisible line. This fragmentation revealed the intense tidal forces present near such an enormous planet. A comet is never a perfectly solid stone. It can be fractured, porous, and genuinely vulnerable whenever gravity pulls harder on one side of its body than the other. That same breakup also reshaped the entire drama of the event itself. Instead of one single impact, the planet absorbed an entire sequence of separate strikes, with each fragment arriving in turn. The shattered comet became a vivid, visible lesson in just how powerful planetary gravity can truly be. Giant planets act as gravitational gatekeepers throughout the solar system. When comets drift too close, their paths can be bent, shortened, stretched, or completely transformed. Some are pulled into entirely new orbits that bring them back toward the sun far more often than before. Others are flung outward into the darkness and may never return. A few become captured into entire families of comets, traveling together under a giant planet's lasting gravitational influence, much like smaller vessels caught in the wake of an enormous ship passing by. This makes giant planets some of the great sculptors of comet history. Their gravity does more than simply attract nearby objects. It actively edits their future paths. A small icy body might drift along one steady path for ages, only to pass near a giant planet and leave along an entirely different course. Its destiny quietly rewritten in a single close encounter. Certain comets follow paths so extreme that they plunge into the innermost solar system and skim dangerously close to our own star. These are the daring wanderers of comet science. As they approach, solar heat becomes intense, and their surfaces begin erupting violently with escaping gas and dust. The closer they pass, the more dramatic that awakening can become. Some survive the ordeal and swing back outward again, forever changed but still largely intact. Others crack apart, fade, or disappear entirely into the sun's overwhelming glare. Their paths are dramatic precisely because they turn our own star into both a spotlight and a genuine hazard all at once. From Earth, we might witness a brilliant flare of sudden activity. Up close, that same comet is being tested simultaneously by heat, radiation, and gravity, a frozen relic racing directly through a furnace. For the most extreme sun-skimming comets, that close encounter isn't simply a close call. It is, quite often, the end of their story entirely. As they plunge near the sun's surface, their ices erupt violently away. Their dust streams outward in every direction, and their fragile internal structure can break apart under overwhelming stress. Some are small enough that they simply evaporate completely, leaving behind no surviving nucleus to continue any further orbit. Others fragment first, producing brief streaks of brightness before fading away into nothing at all. These disappearances are never simple failures of observation. They represent the genuine physical destruction of ancient bodies happening in real time. A comet may spend millions or even billions of years perfectly preserved in cold darkness, only to be entirely undone during one single blazing passage near the sun. In that final approach, our star becomes a vast cosmic furnace, returning the comet's material back into space in one last, brilliant burst of light. A solar-watching spacecraft has quietly discovered thousands of these sun-grazing comets over the years. A spacecraft originally built to study our sun ended up becoming one of history's greatest comet hunters almost by accident. From its unique vantage point in space, it constantly watches the region surrounding our star, an area where many faint comets would be completely impossible to spot from the ground due to overwhelming daylight and glare. Its instruments block out the sun's bright central disk, revealing tiny objects rushing through the surrounding light. Over many years, this steady, patient watch has uncovered thousands of small sun-grazing comets, many belonging to related families that may all be fragments of older, much larger parent comets. Some appear briefly and vanish almost immediately. Others sweep past like sparks flying near an open fire. This achievement is remarkable because it reveals just how much activity hides in places our own eyes simply cannot search. Around the sun, small icy bodies are constantly arriving, glowing briefly, breaking apart, and disappearing again, entirely unseen by anyone without the right instruments. Comets originating from the icy region beyond the outermost planets often return on schedules that feel almost humanly imaginable. Some of these comets settle into orbits that bring them back within decades rather than centuries or millennia. Their paths have typically been reshaped by the gravity of the giant planets until they become regular, repeat visitors to the inner solar system. That regularity makes them especially valuable to scientists, since they can be observed again and again across multiple visits. Each return reveals how their surface changes, how much material has been lost since the last passage, and how sunlight continues to reshape an icy body over time. These are not one-time wonders. They are repeat messengers, arriving again and again from the outer neighborhoods surrounding our solar system's planets. Other comets follow far longer paths, sometimes taking thousands of years to complete a single orbit around the sun. Some travel on such extraordinarily stretched paths that one full trip can outlast entire civilizations. They may appear only once within all of recorded history, brighten briefly for a few weeks or months, and then vanish back into darkness for thousands of years at a stretch. Their orbits carry them far beyond the planets before gravity slowly, patiently turns them back around again. This makes every single appearance feel genuinely rare, almost haunting. The people who witnessed one such comet long ago may have left behind only scattered fragments of writing, carved stone, or half-remembered stories. The next generation of observers may belong to an entirely transformed world. These extraordinarily long journeys remind us that our solar system keeps time on scales that stretch far beyond any single human life. A comet can visit the sun, depart again, and not return until languages, nations, and entire landscapes have been utterly transformed. The distant reservoir surrounding our solar system may hold billions of frozen comet bodies. This outermost region is thought to surround our entire solar system like a vast, distant swarm, so far away that all of the familiar planets would appear as nothing more than a tiny central cluster by comparison. Scientists infer its existence from the arrival directions and orbits of long-period comets. If the underlying model holds true, it likely contains an enormous population of icy bodies, left over from the solar system's formation and scattered outward long ago by the gravity of the giant planets. Most of them never travel anywhere near the sun. They remain cold, dark, and almost perfectly hidden from view. It's a genuinely staggering idea. Our entire solar system may be wrapped inside a remote cloud of ancient objects, too faint to ever see individually, waiting quietly until gravity eventually sends a few tumbling inward as rare, brilliant visitors. Passing stars can occasionally disturb comets resting within that distant, outer cloud. Our sun does not travel through the galaxy in complete isolation. Across immense stretches of time, other stars occasionally pass close enough for their gravity to gently tug at the outer edges of our solar system. For objects drifting within that distant comet cloud, even the slightest disturbance can matter enormously. A tiny shift in direction might send a frozen body drifting deeper into space, or turning inward toward the planets and the sun. Broader gravitational tides from our galaxy can also slowly reshape these distant orbits over time. This means a comet's eventual arrival may quietly begin with nothing more than a gentle nudge from far beyond our entire planetary system. A passing star drifting quietly through our sun's neighborhood, setting an ancient world of ice on a journey that ends, sometimes millions of years later, as a glowing presence in someone's night sky. A comet's orbit can even be gently altered by its own escaping jets of gas. Gravity is never the only force guiding a comet through space. When gas erupts from its surface, it escapes in narrow jets that can push the nucleus slightly in the opposite direction. That effect is tiny compared with the pull of planetary gravity, but over time, it can genuinely alter a comet's path. Because these jets switch on and off depending on which regions face the sun, their push is uneven and difficult to predict with total precision. This is one reason astronomers must periodically update their calculations of a comet's orbit after fresh observations. The body isn't simply falling passively through space like an inert stone. It is leaking, gently thrusting, and constantly responding to heat as it travels. Every outburst carries material away, and every escaping stream gives the nucleus a tiny, invisible shove. In this quiet way, a comet actively participates in shaping its own wandering path through the solar system. Spacecraft that have visited comets up close have revealed cliffs taller than skyscrapers rising from their fractured surfaces. Instead of smooth, simple balls of ice, these worlds often show steep walls, fractured terraces, shadowed pits, and rugged, uneven slopes. On a body with such weak gravity, cliffs can rise to extraordinary relative heights compared with the size of the world itself. They are shaped by sublimation, gradual collapse, shifting dust, and the slow weakening of material as buried ice quietly escapes from beneath the surface over time. A cliff on a comet isn't carved by flowing rivers or falling rain the way it might be on Earth. It is sculpted instead by sunlight and vacuum, by material slowly disappearing rather than flowing away. Standing near a drop like that would feel almost surreal, with a horizon curving sharply nearby, a completely black sky overhead, and ground made from an ancient mixture of dust, ice, and fragile stone beneath your feet. One historic mission discovered towering pits scattered across the surface of a particular comet it studied up close. These deep circular openings had steep walls and shadowed interiors, resembling entrances leading into the body's hidden internal structure. Researchers believe some of them may form when buried ice sublimates away, leaving cavities that eventually collapse inward. Others may expose deeper layers or naturally weak zones beneath the outer crust. Their walls revealed textures, ledges, and unusually bright patches that hinted at fresher material lying just beneath the surface. This discovery made the comet feel far less like a simple, uniform lump and far more like a genuinely changing landscape with real internal architecture. Each pit offered a small clue about how heat moves through the surface, how hidden voids develop over time, and how material eventually fails under such remarkably weak gravity. That mission transformed a distant, blurry point of light into an actual place, complete with its own geography, hazards, and quiet secrets. That same historic mission also released a small lander that became the very first machine to gently touch down on a comet's surface. The target world had almost no meaningful gravity at all, making the landing incredibly difficult to control. Harpoons and anchoring systems were designed to hold the small craft firmly in place, but the actual touchdown didn't go entirely as planned. Even so, the moment was genuinely historic. Humanity had successfully placed an instrument package directly onto a comet's surface, joining imagination with careful engineering in a truly breathtaking way. A frozen body that had spent ages quietly circling the sun was suddenly being gently touched by a machine built here on Earth. That mission showed just how far exploration had come. We were no longer limited to simply watching comets through distant telescopes. We were now arriving at them directly, gently, precariously, and with tremendous curiosity. The small lander actually bounced across the comet's surface before finally coming to rest. Its landing became even more dramatic, because the little craft didn't simply stay where it first made contact. In the comet's remarkably weak gravity, it rebounded and drifted quietly across the surface, before finally settling in a shaded location. That unexpected journey made both communication and power generation considerably more difficult, since its solar panels ended up receiving far less sunlight than originally planned. Even so, the lander still managed to return genuinely valuable measurements before its battery eventually faded. The unplanned bounce itself became part of the overall science. It revealed just how strange landing on a tiny comet can truly be, where a gentle contact can suddenly turn into a slow-motion leap. On Earth, our own weight holds us firmly to the ground. On a comet, the rules feel almost dreamlike, where a machine can touch down, rise back up, and drift across an alien landscape, almost like a floating feather. That same orbiting spacecraft followed its target comet closely for many months as it gradually awakened near the sun. Most missions only manage a brief glimpse of a distant world. This particular mission accomplished something considerably rarer. It stayed alongside its comet for an extended stretch of time, quietly watching the surface transform as solar heating steadily increased. Activity began in small, isolated regions, then gradually grew stronger as more buried ice warmed and more dust escaped into space. Jets brightened, the surrounding cloud thickened. The entire environment around the spacecraft became noticeably more hazardous, and scientifically far richer than before. This extended companionship allowed researchers to observe a comet as an ongoing process rather than a single fleeting snapshot. They effectively watched entire seasons of activity unfold across a tiny world, guided by sunlight and its own slow rotation. It felt very much like observing a frozen creature slowly stirring from a long hibernation. The mission revealed that comet behavior is never simple or uniform. It is deeply local, constantly changing, richly textured, and tightly connected to the exact shape of the nucleus itself. That particular comet's nucleus turned out to have an unusual two-lobed shape, one that reminded many people of a simple bath toy. When close-up images first clearly revealed the nucleus, its outline surprised nearly everyone involved. It had two distinct lobes joined together by a narrower neck, a shape many people playfully compared to a familiar rubber duck. The comparison was lighthearted, but the underlying science was serious. A form like this affects exactly how sunlight falls across the surface, where material escapes most readily, how dust moves around the body, and how gravity behaves in different regions. The narrow neck region proved especially interesting, showing intense activity and remarkably complex surface textures. Rather than a simple sphere, this comet turned out to be a world with uneven regions, deep shadows, varied slopes, and constantly shifting illumination. Even a comet's overall silhouette, it turns out, can meaningfully influence its entire life near the sun. That unusual two-lobed shape likely formed when two smaller icy bodies gently collided and merged together long ago. One leading explanation for such a double-lobed form suggests that two separate, smaller icy objects collided at fairly low speed sometime in the early solar system and simply stuck together, rather than destroying one another on impact. During that early, chaotic period, gentle mergers like this may have been fairly common among small bodies drifting through space. If that explanation holds true, this particular comet effectively preserves a record of slow, gradual construction dating back to the earliest days of our solar system. The narrow join between its two lobes may represent an actual contact region, where two entirely separate histories quietly became a single object. That possibility